So the first question is, I will tell you the solution as well as answers. Okay, so what you're going to do is you're going to write this. Okay, like 1A, 3B, like this. Okay, you write this in your fair sheet. Okay.
Oh,
So
okay.
first, it is the question number is 1379. Okay. Electric charge is an integer multiple of electronic charge E. The above statement is proved by, what is the answer? Anyone? Yes, it is proved by which scientist?
Millikan.
Pardon?
Millikan.
Yeah, Millikan is the correct answer. It is 4. 1 is 4. Okay. Say a third. Third is the next. Third. Yeah. A body can be negatively charged by. A body can be negatively charged by giving some remove giving excess electrons to it. Okay, excess electrons to it. Fine. If you want to charge a body negative, you can either give extra electrons to it or take out some protons from it. Fine, everyone. If you have a doubt
Yes.
in any of the answers which I say, please stop me and ask. Okay, fine. Okay, after that, it is the question number is 7. 7. Now they are saying that the electrons are removed, right? Electrons are removed with the negative charge are removed means it's a plus 16 microcoulomb. The seventh is 1. Okay. Any doubt, anyone?
Well, it's one, right?
Pardon? Yeah, 1. Okay. Then 9. The principle of conditional charge is proved by, it is again Millikan's all drop experiment. Okay. 9th 2. 9th 2. And then 10th. 10th is charge an alpha particle. Alpha particle is everyone write this. Alpha particle is double positive charge helium atom. Okay. So what is helium atom? Helium atom is hydrogen helium. So helium atom is having okay, and helium will have in outermost shell there will be 2 electrons. Okay, 2 electrons. Now what I am doing is I am double positive charge. Double positive charge means I am removing both of these electrons. So alpha will be alpha particle will look like this. It will be just a nucleus with 2 protons and 2 neutrons. Okay, so this is alpha particle. Okay, it has no electron. Fine, everyone. Please write this thing everywhere. Write this everything because it will come many times and you will be always doing it wrong. So write everything about alpha particle. Fine. So the charge on alpha particle is it's of course 3.2 into 10 power minus 19. It's double of electron. So the answer is 3. So now see 13. 13 is an important question. Okay. The Fg and Fe. Fg is force of gravitation and Fe is electrostatic. Gravitation is G m1 m2 by r square. Okay. And Fe electrostatic is K q1 q2 by r square. Now two electrons. Okay, two electrons. So what is the mass of electron? It is 9.1 into 10 power minus 31 kg. And what is charge in electron? It is 1.6 into 10 power minus 19 coulomb. Okay. So and distance is 10 centimeter. They're asking what is Fg by Fe, right? Fg by Fe they're asking. Fg by Fe. So see Fg is G, then m1 m2. So it is m square, right? M square divided by r square divided by Fe is K. The charge is E square by r square. So the r square will get cancelled. Okay. So it is equal to G m square by K E square. So G m square by K E square. Now what is G? G is what is the value of G? Anyone? Capital G?
6.67 into 10 power minus 11.
Can you speak a little louder? 6.6 into 10 power minus
11.
11.
Yeah.
Okay, okay. And m square is, I'll write it nicely here. Okay, 6.67 into 10 power minus 11 into m square is 9.1 into 10 power minus 31, the square, okay, divided by k. K is 9 to 10 power 9 into e square. It is 1.6 into 10 power minus 19 square. Now you look at the options. The options is only giving you powers of 10, okay. So because it is only giving you power of 10, I will only be interested in powers. So only powers, okay. So what is only powers? This is 10 power minus 11, 10 power minus 62, 10 power 9, 10 power minus 38. So it is 10 power minus 11 into 10 power minus 62 divided by 10 power 9 into 10 power 19, 19, 38. 38, okay. So minus 11 minus 62 is 10 power minus 73. 9 and minus 38. 9 minus 38 is 10 power minus. This is not my 38 minus 9 is 29. Minus 29. Okay. So it is 10 power minus 73 plus 29. So 73 minus 20, 13 minus 9 for 4. 6 minus 2, 5. Okay. So it is approx 10 power minus 44. And therefore the answer is 4. Okay. 10 power minus 43. Fine. So the 13th answer is 4. Fine. Okay. 13th is done. Next is 20th. Okay. किसी को anyone has a doubt in this? Anything to ask? Only powers are asked. Okay. Only powers are asked. Fine. The next is 20th. Now this is a very good question. Okay. So see 20, a point charge Q1 exerts a force F upon another point charge Q2. So there is Q1, Q2. Okay. And suppose they are suppose same sign. So they exert F like this. Okay. On Q2 also there will be F. Right? What is the magnitude of F? F will be equal to K Q1 Q2 by R square. Fine. Now they are saying that another charge Q3 be placed quite near the charge Q2. Another charge Q3 be placed quite near the charge Q2. So somewhere here Q3 is placed. Now they're saying the force that Q1 exerts on Q2, the force that Q1 and Q2 exert on each other will not change. Okay, so the force on Q2 by Q1 is only dependent on Q1 and Q2. Okay, it is independent of any other charge. So therefore, it won't change. Okay, and therefore the answer is 1. Okay, so Anushka, you understood this?
Yes, sir.
Okay, yes. 20. 21, you know, I've already told you 21 it is 4, right? I hope everyone has marked this. Direct question. 22, two similar spheres having charge plus q and minus q charges are kept at a certain distance. F acts between the two. If in the middle of two spheres another similar sphere having plus q is kept, then the direction is, one second, let me just. So there is a plus q, there is a minus q. Distance F acts between them. Okay, F acts, so F acts on this one like this, F, and on this one like this. Now they are saying in the middle of two spheres another similar sphere having plus q is kept. Okay, similar plus q is kept. Then it experiences a force of magnitude and directions as C. Okay, see. Suppose this distance is d. Okay, then the F value, the green one F, okay, the green F is equal to k q square by d square. Fine. Any problem, anyone? No. What now if this plus q is kept here? The force on this will be C. Due to this plus q, it will experience a force like this. Okay, F1. And due to this minus q, it will again experience a force like this, which is again F2. And the magnitude of F1 will be equal to magnitude of F2, and it will be equal to k q square by the distance will now be d by 2 the whole square. Okay, because this distance is d by 2. Okay, and this is equal to 4 kq square by d square, and this is one of the forces F1. So the net on F is 2F, which is equal to 8 kq square by d square. That is equal to 8F, right? Correct. And it is in the same direction as the, one second. 8F towards which one? Towards minus q. Okay, 8F towards minus q. Fine. The answer for 22 is 3. Anyone has a doubt in this?
Sir, isn't that the only option which is towards minus q?
Correct, exactly. So no need to solve all this. You can directly say from minus, from the direction. Good observation. Okay, next is 22 के बाद है 23, 24. Okay, 23. See, so two balls carrying 7 microcoulomb and minus 5 microcoulomb attract each other with a force F. If of charge minus 2 is added to both, the force between them will be. See, the F is K 7 5 by R square. The new F dash is C K. The new charge on 7 will be 5, because when you add minus 2 to 7, it is plus 5. And when you add minus 2 to minus 5, it becomes minus 7. So it becomes minus 7, right? It doesn't matter. The force does not change, right? Understood? The force between them will be, because it is 35, this also produces 35. So this is F, this also. Understood? Okay, so 23, the answer is 1. 24. The force between two identical spheres charged with the same charge is F. If 50% charge of one sphere is transferred to another sphere, then the new force. See, it's simple, identical, right? Identical. So F is equal to K, Q by r square. Okay, the new force will be F is equal to K. 50% is removed from 1. So the first becomes Q by 2, right? Suppose you have 20 coulomb, then you become 10 coulomb, right? 50%. And the other becomes how much? 3 by 2. 3 by 2 Q, right? So R square. So the new force will be 3 by 4 of the old force. Okay, it is obvious. F dash is 3 by 4 F. Okay. So 24th answer is 1. Fine. And then 26th. 26th. Two charges or of 1 microcoulomb and 5 microcoulomb placed 4 centimeter apart. The ratio of both charges. This is always 1:1. It doesn't matter. Like whatever is the charge and whatever is the distance, whatever is if this experience F1, this also experience F1. Okay, so they are same. So the 26th answer is 1. Okay. 28. Intensity of electric field at some point distance also on axis of an infinite long pipe having charge per unit length. Oh, that is proportional to inversely proportional to R. We found that E is 2k lambda by R, right? For a infinitely long pipe, right? So the answer is 3. I think inversely proportional to R. 20, it is done. 26, 20, 29, 32, 29. 29 is easy. 29 is the given figure, the direction of electric field at A will be. So there are two charges. A is X and Z. It is along Y. Along Y. If you don't understand why it is along Y, please ask me. Along AY. So the answer is 2. Anyone has a doubt in
Why is it along Y?
See, the figure is like this, right? And there is a plus Q here and there is a minus Q here, correct? Correct?
Yes, sir.
At A, they're asking the electric field. So due to plus Q, the electric field is like this.
Yeah.
Right. Due to minus Q, the electric field is like this. Right.
Yeah.
Both of these are equal charges. So, they are equal in magnitude. So the resultant will be like this one. If you add these yellow
Yes,
and green vector, it will be along red vector. So it is AY. Understood?
Yes, sir.
Okay.
Thank you.
So 32. 29 ke baad 32. Okay. 32 is two charges 9E and 3E are placed at distance R. The distance of the point for the electric field energy will be 0. So 9E, 3E, and the distance between them is R. Try where is electric field 0? Where is electric field 0? So see, let it be X distance. So electric field due to 9E will be like this, due to 3 will be like this. So it will be X by 9. Sorry. So electric field due to the 9E will be K 9E by X square. This will be equal to K 3E by R minus X whole square. Fine. So if you cut this, you get 9 by 3, which is 3 is equal to X by R minus X the whole square. Okay. So now now how to solve this? See, this is a square, right? And this is 3. So what you do is you say either X by R minus X is equal to root 3 or X by R minus X is equal to minus root 3. Fine. Math is fine. Now then you solve it. This is X is equal to R root 3 minus X root 3. X times 1 plus root 3 is equal to R root 3. X equal to R root 3 by 1 plus root 3. And if you solve this, you will get X equal to minus root 3 R plus root 3 X. X times 1 minus root 3 is equal to minus root 3 R. X equal to minus root 3 R by 1 minus root 3. Fine. Now I will try to understand these answers. Okay, these numerical answers. See. Because 1 minus root 3 is more than 1, so I'll not write it like this. I'll write it like this: root 3 minus 1. Okay, fine. Okay. So this is a root 3 by root 3 minus 1. Negative multiplied. Okay. And yeah, this is R root 3 by root 3 plus 1. So okay, now tell me, See, if you think of this answer, and now listen carefully. Okay? Root 3 minus 1. Root 3 minus 1 is 1.73 minus 1, which is 0.73, right? If you see the denominator, it is 0.73, right? And the numerator is 1.73, correct? Okay, all of you have understood why I have written point is inside and point is outside. Does everyone understand?
Yes, sir.
See, I told
Yes, sir.
that I said that x is distance from here, right? X is the distance from here. So if x is greater than r, of course the point will go outside, right? Understood? That's why. mm, so which one of this is our answer? The inside point, okay? The inside point is the answer. So it is this one, r root 3 by root 3 plus 1. Now, if you see this, there is no answer which is in this form, but all the answers have nothing in the, only r in the numerator. So see, I'll just root 3 by root 3 plus 1. You just divide everything by root 3. So it is r divided by 1 plus 1 by root 3. The answer is r 1 plus 1 by root 3 from the, which one charge? From the 9e charge. So it is B option, okay? 2 option. So therefore 32 is 2. Fine. Okay.
Yeah.
32 is 2. Okay, quite long. Yeah, see, there was another method of doing this. There's no calculation required. Simply use, common sense. See, it has to be very simply. If it is a 9e and a 3e, see, this charge is more, right? Q1 is more. So it has to be farther away from Q1, right? It has to be farther away. It has to be somewhere here. Correct? It should be somewhere here, no? It is.
Yeah.
It has to be more than half side or right side, correct? Half side, right side. Everyone gets this.
Yes, sir.
Okay.
Yes.
And then because it is so only, so that means the distance from 9e should be greater than 0.5 r, half r, right? It should be greater than half r. Okay, and only r by 1 plus root 3. I think only this second option is such that it is, satisfying that its distance is more than half r from the origin. Fine, from the 9. 32 is done. 34. In the figure, distance of point A where the electric field is 0 is. I hope everyone is writing the option because you have to check your answer key. Okay. बाद में पूछना मत सर इसका आंसर क्या उसका आंसर क्या. Okay. 34 in the figure, distance of the point from A where the electric field is 0. 10 microcoulomb, 20 microcoulomb. 34, can anyone tell me the answer? I mean, I don't want to solve anymore. What do you got at answer? 34.
I got two the second one.
Yeah,
Second
30.
one.
No, second.
34. Common answer will be taken as correct answer. Yes, 34, please.
So I got third option, 33 centimeters.
It is 33 kind of that. Yeah, 33 type. Yes, it will not be 10. See, 10 है, 20 है, ये distance x है, ये distance होगा 80 minus x. ठीक है. So electric field बोला है, where is electric field? 0. So electric field 0. This is 1.414 plus 1 to 2.414. X is equal to 80 divided by 2.414. So I think 80 divided by 2.414 is 80 divided by 2.414 is 33. Yes, it is 33. So it is 3. 34 is 3. And 34, then 55, 58, 59. 55. 55 for a dipole, the value of each charge is 10 power minus 10 at coulomb, 10 point minus 10 coulomb, and separation is 1 angstrom. Okay, see, 1 angstrom is, I forgot what, how much is 1 angstrom?
What's a dBi?
DBi is basically coulomb into meter is dBi. 1 coulomb into 1 meter is dBi. Okay, so 1 angstrom is 10 power
Okay.
minus 10. Okay, 10 power minus 10 meter. So you just have to write in SI unit. Okay, so kitna 1, each charge is 10 power minus 10, right? But separation is 1 angstrom, so it is 10 power minus 20. So I think I'm wrong, therefore it is not, dBi is not that. Once again, just let me check what is dBi. 1 dBi. Oh, dBi is defined as 10 power minus 18 stat coulomb centimeter. My God. So 1 dBi is 10 power minus 18 stat coulomb. What is divisible by 1 second? Okay, just let me check how much is, what is 1 stat coulomb. Okay, see, you have to write it this way. So just don't, just forget everything. You just write this 1 dBi is equal to 3.335 into 10 power minus 10 power minus 30 much, minus 30, yeah, 10 power minus 30 coulomb meter. Okay, in a side coulomb meter. Okay, so 3.335 into 10 power minus 30 coulomb meter. Okay, this is 1 dBi. So now our dipole, in this question, our dipole has ST. 1 second. Okay. 1 stat coulomb centimeter. Just a second. It is also equal to 1 dBi is also equal to 1 10 power minus 18 stat coulomb. Okay, stat coulomb cm. This is which we'll use here because they have given that it is, the charge is 10 power minus 10 st coulomb, and separation they have given 10 power 1 angstrom, which is 10 power minus 10 meter, which is equal to 10 power minus 8 centimeter. So therefore see, this is 1 d, this is how much dBi, this is 10 power minus 10 is charge stat coulomb into centimeter, in 10 power minus 8 centimeter. So this is 10 power minus 18 st centimeter, right, which is equal to 1 dBi. So it is 1 dBi. The answer for 55 is 1. Even if you have not done this, I am removing this question from the denominator. Okay, this question will not be marked. Okay? Not considered. Anyone has done it correct? 1 dBi.
So I guessed it. So I got 10 power minus 18.
Okay.
Yes, I just wrote 1.
Pardon? You write 1.
I just wrote 1
Yes.
randomly.
Okay. Good guesses. Okay. Next is 55 हो गया. 58. 58 कहाँ गया? Unit of dipole moment is, it is simple, coulomb meter. Okay, coulomb meter, 58 to coulomb meter, coulomb into meter. And then 59. We have done this, this derivation, and I think, what is the answer for 59? Do you remember the derivation? Anyone?
The second one.
Second, no, it's not second one. No, it's not second one. It is at any angle theta, right? It is either 3 or 4. It is either 3 or 4. You forgot the derivation.
What?
It is either 3 or 4. I'll just check. The question is the electric potential at a distance from the center and electric potential due to light. KP cos theta 1. You are saying it is KP cos theta 1 r square. Cube होता है. KP cos theta 1 cube. One second, okay, I'm trying to search the answer. Very small electric dipole. Theta. Axis of dipole. Okay, what I'm confused about this. What is answer according to you? What is the answer according to you? Hello. Anyone? Any input?
It looked like the most similar formula that I knew of.
Like the second one.
Yeah, the second one.
Okay. See, we can guess some results. Okay. See, electric dipole is like this, no, plus q and minus q. Okay. And the electric potential distance r from the center and make an angle theta from the axis. So it is like this. Okay. If this angle is theta and distance is r, what is the dipole? What is the potential at this point? Okay. So tell me, what is the potential at any point on this axis? Any point on this axis, what is the potential? Here, what is the potential? It is kq by r1 plus k minus q by r1. So kitna hoga? What is the potential? Please don't be just silent spectators. You will not learn anything out of this class. And what is the point of coming to this class if you are just going to sit and watch?
Volume is a little low.
Pardon?
Yeah, now it's fine.
I'm asking what is the potential on any point on this line? Isn't
Zero.
it zero? It is zero, yes, because you are equally distant and the charges are negative. How can you get by putting what value of theta? By putting what value of theta you will be on this line?
90.
90 pi by 2, right?
Yeah.
Which option when you put theta is 90 gets you voltage is 0? That is our answer, right? Okay. First, if you put theta is 90, sine 90 is 1 is not given. Second is
Cos
giving,
theta.
right? Third is giving you theta 90 cos 90 0. It is giving you kp by r cube, right? It is not giving 0. Fourth is also not giving 0. Understood? Therefore, the answer is 2. Fine. Understood?
Yes, sir.
sir.
Okay, 59, 62, 63. 62. The force of charge is a point of the charge to double the distance. We'll write force on a charge. situated on the axis is a point. Distance from the midpoint of a dipole is. This is dipole minus q plus q. This is center point. Situated on the axis at a point. Yes, axis. At a point. At a distance from the midpoint of a dipole. At a distance from the midpoint. ठीक है चलो यहाँ पे एक charge है. The distance is d. If the charge is shifted to double the distance, the acting force will be. Okay. Okay. So we need electric field on the axis of a dipole. Okay. What is the electric field on the axis of a dipole? कितना होता है बताओ? Formula याद है? Please go to your result page and tell me electric field on the axis of a dipole. Oh, that is for far away points, right? That 2 kp by r cube is correct, but it is for far away points, right? Saksham.
So isn't that kp by r?
Yeah, okay, it's kp. It should be 2 kp by axis पे 2 होता है. हाँ. Axis of a dipole is 2 kp by r cube. Okay. Okay. See, axis of a dipole, it is something 2. No, if r is greater than d, then it is 2 kp by r cube. Okay. If r is not greater than d, okay. See, this is the answer. Okay. 1 by 4 pi epsilon naught 1 by r raised to 4 2 pr by 1 minus d by 2r. Oh my god, this is the answer. No, I think they're asking for then this. The answer is f by 8. Okay. We'll use this only. Okay. If you are doubling the r, if you double r, it becomes 2r. Then the force electric field becomes e by 8. Okay. The force also becomes f by 8. So the answer is 4. You'll use this only. And then afterwards, this is 62 ke baad 63 for a point situated 63 for a point situated on the equatorial line of equatorial electric dipole, the direction of electric field intensity is equatorial line. Equatorial line is this line. Okay, minus q plus q. For a point situated is the direction of electric field intensity is opposite to the dipole moment, right? 63 is 2. And then 65. The work done in rotating electric dipole of dipole moment p in electric field through an angle theta. Okay, see, I told you that we wrote a formula, right? Can you go back and see that the work done is minus pe cos theta 2 minus cos theta 1, theta final minus theta initial, and you have to check whether there is a negative sign here or not. Quickly check it. And when P is in line with E, theta is 0. If theta is 0, theta initial is 0, and therefore cos theta initial is 1. So therefore this becomes 1. So you have minus PE cos theta minus 1, which becomes PE 1 minus cos theta. Okay. So this is the answer. PE 1 minus cos 65 is 1 anyway. Even if minus is there or not, the answer is same. Okay. P1 minus cos theta. 65, 69, 75. 69 is easy. P E torque tau is equal to P cross E. Then is equal to P E sin theta. So when torque is maximum when theta is 90. So maximum 90.69 is 1. And 69, 75, 79, 75. Yeah, see 75 में concept है. The closer electric field lines are, the more is the electric field. So of course, EA is equal to EC, and both of these are greater than EB. Fine. Okay, so, understood. The more closer, densely packed electric field lines, more is the electric field. So denser E lines implies more E magnitude. Okay, more E magnitude. Okay. So therefore, EA is equal to EC greater than EB. 75 is 3. If the electric flux entering and leaving an enclosed surface is phi1 and entering is phi1, entering is phi1, leaving is phi2. The charge is phi2 minus phi1 by epsilon. Phi2 minus phi1 by epsilon is 4. Entering क्या होता है? Entering अंदर आ रहा है, right? Entering is inside. Inside बोल रहा है phi1 और outside body से outside जा रहा है phi2. So basically positive charge is phi2 leaving. So it is phi2 minus phi1 by epsilon. Minus phi1 by epsilon. Okay. 4th. Any doubt?
Wait, so I didn't get this one.
C.
So what to multiply?
Pardon?
So by the, like, if you select pi is equal to q enclosed by epsilon naught.
Yeah.
Shouldn't it be phi 2 minus phi 1 into epsilon naught?
Oh, one second.
I got the first answer.
Flux is equal to electric flux entering the electric charge is q enclosed by epsilon naught. Oh yeah, it is, sorry, this is wrong. This is 2. It is 2. It is 2. Okay, if you have not still understood why it is 2, ask me. Are you confused why it should be phi1 plus
So won't the total
or phi1 minus phi2? It's a doubt again.
both is?
Yeah.
Yeah. Oh,
Pardon?
isn't the total flux being want to be when you add both the fluxes? So why is it phi1 minus phi2?
When you, oh, you are asking me why is it not A, right?
Yeah, why is it not? Yeah.
Okay, listen. Suppose there is a positive charge. Okay.
Yeah.
Fine. And so tell me, if the positive charge, the lines will be going like this, right? Okay. So if I ask you how much flux is leaving, how much flux is leaving, Q by epsilon naught, right? This you will write, no?
Yeah.
Right? You will say the flux leaving is Q by epsilon naught, correct?
Yeah.
Suppose it is a minus Q, then the lines will be coming like this, correct?
Yeah.
You will say the flux entering, right? And you will not say leaving, you will say flux entering is equal to Q1 by epsilon naught. Q by epsilon naught, correct?
Yeah.
You can also say it like this: flux leaving is minus Q epsilon naught. Do you understand the difference?
Okay. Yeah.
So that's the point. See, if phi1 is leaving, that means inside positive charge, right? If phi1 is leaving, no, phi1 is entering, right? In the question it is given phi1 is entering. Yes or no?
Yeah.
If phi1 is entering, that means inside, corresponding to phi1, there is a negative charge, right?
Yeah. Okay.
How much negative charge? Minus phi1 into epsilon naught, correct?
Yeah.
And if phi2 is leaving, then there is a positive charge inside. How much positive charge? Phi2 into epsilon naught.
Okay, and then you add both.
You add both. There's a total charge which is 2. Okay, good doubt. This is 79, and then 82. If the electric field on the Gauss surface then is emerging out, so it will contain second positive charge. Okay, then the surface will contain positive charge. Okay, easy. 82, 84, 84, 84. The electric field intensity at a point located at distance r from the center of a spherical conductor into the radius charge E is equal to electric field intensity at a point located at distance r from the center of a spherical conductor. Oh, conductor. Keyword is conductor. Okay, conductor है. ठीक है, इसका मतलब all charge will go to the outside periphery, right? Okay, so what is electric field inside?
0.
0. Good. Is 0, 4, 0. If it was a non-conductor, then the answer would be 2. Okay, right? Okay, little bit. So if it was a non-conductor, the answer would be KQR by R cube, capital R cube. Because then it becomes proportional to R, right? It goes along like this, E versus R. For a non-conductor, NC. For a conductor, it is like this: 0 inside, outside 1 by R square. For a conductor, okay. Fine. 84 is done, and 86. 86. This electric field contains a uniformly charged sphere of radius r. Uniformly charged, right? If it is uniformly charged means distance. Okay, uniformly charged means everywhere there is charge, right? If there is everywhere there is charge, that means of course it is a non-conductor. Okay, and therefore the answer is like this. Okay, so electric field is answer is 86 is 2. Fine, everyone. Okay, now what you do is, I have told you answers. Go to your answer key. Check your answers. Tell me how many marks you have got doing +3 and -1. Okay, +3 for correct, -1 for incorrect, and 0 for if you have left it. Right, wrong if you have left it. Okay, quickly do it.
So we don't count the 55th one, right?
Yes, you don't count the 55th question. सही टाइम पे लाइट गई एकदम, मजे एकदम लाइट चली गई ऐसे ही फालतू में. हाँ, एकदम अभी ऐसे. अपना हॉटस्पॉट दे. नहीं, हॉटस्पॉट तो है मेरे पास.